Hi everyone. In today's video, I'm going to go over using a 2x2 table to answer questions related to sensitivity, specificity, positive predictive value, aka PPV, and negative predictive value, NPV. This is an example of how I draw my 2x2 table. Now, you may be asking, in what scenario would we be asked these type of questions? Good question. It's when they want to measure how good a test is at doing its job of detecting the presence of a specified condition. This biostat topic seems pretty high yield for step 1. So in this video, I'm going to go over these terms in the most simplified way to help you better understand them, and then give you mnemonics that I came up with that help me memorize them. So without further ado, let's begin. Start off with a blank 2x2 table. On the left side, you'll label test result positive and negative. Now go down the row and fill in the corresponding positive and negative signs. Next, label the columns for the presence of condition with yes on the left and no on the right. Now let's label each box. So if the test result comes back positive and the person indeed has the condition, which means yes for the presence of condition, then the test was true. It truly tested a positive, which means the person truly has the condition. If the test result comes back positive and the person does not have the condition, meaning no for the presence of the condition, then the test was false. It falsely tested a positive when the person really does not have the condition. A negative test result for no presence of condition is a true negative, and a negative test result for the presence of condition is a false negative. So you see, the total of the 4 boxes is the total number of people in the study. The total of the yes column is the number of people with the condition, and the total of the no column is the number of people without the condition. This leads to the next topic, sensitivity versus specificity. So before we continue, I want to bring up this table again. Notice that I highlighted the boxes true positive and true negative, pretty much the true values. Now, how I reason it is if you want to see how good a test is, then you want to focus on the percentage of true outcomes, because that means the test did what it's supposed to do. It tested positive for those who have the condition and negative for those who don't have the condition. So these two are important numbers used when calculating sensitivity, specificity, PPV, and NPV. Later on, you will notice that the trend of what distinguishes sensitivity and specificity from PPV and NPV are the groups, or the denominator numbers. This will make sense very soon. For sensitivity, I think of how sensitive is the test at detecting those who have the condition. So number of true positives divided by number of people with the condition. The group, or the denominator, in this case, is the number of people with the condition. This is essentially saying, out of everyone who really has the condition, so the sum of these 2 boxes, how many were able to be detected by the test, which is a positive test result. For specificity, I think of how specific is the test at detecting those who do not have the condition. So number of true negatives divided by number of people without the condition. The group, or denominator in this case, is the number of people without the condition. This is essentially saying, out of everyone who really do not have the condition, so sum of these 2, how many were able to be detected by the test, which should be a negative test result. And this is the mnemonic that helped me remember. The following is truly sensitive and specific. Sense the positive people. Specifically, stay away from the negative people. Try to say this a few times. Sense the positive people. Specifically, stay away from the negative people. Hopefully, this helps you remember that sensitivity associates with the true positives and specificity associates with the true negatives. And this is for your reference. Next, positive predictive value and negative predictive value, PPV and NPV. What helped me was breaking down the terms. I think of a predictive value as a value, so a number or percentage, associated with how good the test result, whether positive in PPV or negative in NPV, is at predicting the presence of the specified condition. Meaning, if someone's test result is positive, does that person really have the condition? So PPV will give us a ratio or percentage based off a study to determine how good is the test at figuring out those who really have the condition. A higher PPV is good. It means the test has a higher chance of figuring out those who really have the condition. To calculate the PPV, we look at the positive test row. And the sum of the two boxes is the total number of people tested positive. I think of PPV as asking how good is the predictive value of a positive test, aka how true is a positive test result. So the number of true positives divided by the number of people tested positive. The group or denominator in this case is the number of people tested positive. Vice versa with NPV. How good is the predictive value of a negative test, aka how true is a negative test result? A higher NPV is good because it means the test has a higher chance of figuring out those who really do not have the condition. To calculate the NPV, we look at the negative test result row. The sum of the two boxes is the total number of people tested negative. And I think of PPV as asking how good is the predictive value of a negative test, aka how true is a negative test result. So the number of true negatives divided by the number of people tested negative. The group or denominator in this case is the number of people tested negative. This is how I remember PPV and NPV. I see the word predictive and I associate it with test results, because you can use test results to predict, but you can't really use the presence of a condition to predict because there's no need for it. It doesn't make sense. This is for your reference. So again, see how this is ordered. The columns associate the presence of a condition with sensitivity and specificity, while the rows associate test results with positive predictive value and negative predictive value. To quickly summarize, if we want to measure how good a test is at doing its job, we could calculate its sensitivity, specificity, PPV, and NPV. That's the end of my video. Hope you find this helpful and see you guys next time.